All right, we're going to wrap up section 3 in this video where we're going to do a couple of things. One, we're going to evaluate logarithms, okay, by hand. And it's very important for you to do this. The first thing I'll say, observe again, on your calculator, you have a log button and you've got an ln button, or like so. This is base 10, the so-called common base, and then this is base E right here, okay? That's the natural base. Look at your calculator now and find those buttons. And then I'm going to ask you something else, okay? I'm looking at mine right now. I know right where they are. They're on the left-hand side. Under the second button, there's the log, and then right below it is ln. Very important buttons. Tell me, do you see a log base 5 or a log base 4 or a log base 2 button? No, you don't, do you? So you cannot go after this problem with a calculator unless there is a formula later in this chapter that'll do it for you. You got to put it into a formula. But in the meantime, we'll assume we don't know how to find these logarithms. So that's the first thing. We had about 5 of these. They're very quick. And what we're going to do, and what they do when you do this yourself, is you start to understand and feel better about the notation. So let's give this a shot. Let's work on this one. It says log base 5 of 1 over 25 equals, we don't know. Okay, what I learned in textbooks is put an X there, because you don't know what it is. We do that all the time in algebra, don't we? Then what you do is write it in the equivalent exponential, like we were doing in the last video, exponential form. Okay, the way that looks is, well, the base is 5, the power is, and the other thing is, well, the other thing is 1 over 25, and the power that comes along is x. So it goes 5 to the x is equal to 1 over 25. That's how I interpret a log expression. 5 to what power is 1 over 25? Okay. What it requires of us is to look at that and go, well, I've got 5 to the x here, and on the other side, I think that's 5 to the, guess what? It's the negative 2 power. Flip it over and square it. Answer, x is negative 2. And then it's really good to say this. So therefore, log base 5 of 1 over 25 is negative 2. If you get to the point where you're able to look at it and go, oh, that's negative 2, then you know logarithms, okay? Until you get there, we're going to do it this way. If I give a test and I go evaluate these logarithms by hand, and you're able to just do it in your mind, great. Okay, there's not much work to it at all. It's just I know you're looking for the power of the base. But we're going to keep doing it this way, okay? So, okay, let's look at the other examples. This one says log base 4 of 4 is, I don't know, guess what? I'm going to put an x there. That's where I put the x. So now I can say x marks the spot, so to speak. We're going to go, well, the base 4 to the power x equals, 4 again. This one's not so tough, is it? On this side I have 4 to the x. On this side I have 4 to the 1, right? Actually, it reminds me of section 6 where they go, there's a property that says if the bases are equal to each other, the powers have to be equal to each other. So we could say x is equal to 1, and therefore log base 4 of 4 equals 1. And that's one of the properties in the next section. A basic property is this one. In other words, 4, the base, to the power 1 equals 4. All right. Or you can think of it looking like this. Log base 4 of 4 to the 1. Remember last time I said, hey, these guys cancel each other out and you get 1. That's another way of doing the same problem. This one could have been done log base 5 of 5 to the negative 2. Cancel, negative 2. Do you see that? If you want to look at it that way, you can do that. You want to try it on this one? Let's try it on this one. What power of 2 is 32? log base 2 of, calculator time, 2 to the 5th. Cancel, answer is 5. We just computed it. Okay, that's a fast way of doing it if you know what you're doing. If not, what we do is we go 2 to the x power equals 32, and we have to figure the x out, okay? Forgot this part, it's equal to x, and then I jump down here, right? Well, on the left-hand side, you've got 2 to the x. On the right-hand side, you still have to figure out that's the 5th power, and now you can say x is 5, and then finally you can say the statement, log base 2 of 32, I'm going to get cute here, is log base 2 of 2 to the 5th is 5. Cancel. See that? Pretty cool. 2 more, and then we'll graph a curve, and that'll be it for this video. So let's take a look at a couple more. You can pause, you can look at this and see if you can figure this out. This one is, you might want to write, okay, log base 7 of 1 equals, gee, I don't know. All right. So 7 to I don't know is equal to 1. People stare at that and stare at that and stare at that. What is that really equal to? What power gets you? Yeah, x is 0. So here's another thing you want to write down. Log base 7 of 1 is 0. In fact, that's true for whatever base you're talking about, because the 0 power gets you 1. That's the only one that gets you to 1, unless the base is 1, which is silly to say. Okay. Look at that. So these guys here actually have these hidden nuggets of wisdom. This one could have been written log base 7 of 1 is log base 7 of 7 to the 0. Cancel, and we get 0. Okay? All right, last one. Okay, so let's say we don't do it that way. We simply say log base 11 of the square root of 11 is equal to x. So 11 to the, are you getting faster at this? The 11 to the x is equal to square root of 11. What kind of power is it on the right-hand side there? 11 to the x is 11 to what power? 1/2 power. The square root's the 1/2 power. Ha-ha! So therefore x is 1/2. Then we would say log base 11 of the square root of 11 is equal to log base 11 of 11 to the 1/2 power, cancel, is 1/2. All right. So computing logs by hand, you get homework in there, and this is how I do it. You can do it in different ways, but I think if you're a raw recruit, I would suggest always just put the x out there and then create the exponential equation and figure it out. Okay. It's always a matter, though, of looking in there and going, what power of the base am I looking at there? Okay, the last thing we'll talk about is how to graph a logarithmic function. There's only a couple in the homework for you to do. And so let's say I have an example here. We're going to graph y is equal to log base 3 of x. Okay? What I'm saying is it's easier to rewrite this in exponential form. So that means write 3, okay, what's the power? Y is equal to x, or you can say x is 3 to the y. And then from there, what you can do is look at a bunch of ordered pairs. I don't have a graph here. Oh, well, that's too bad. So in other words, just turn it into exponential, because we can see exponentials better than logarithms, unless you're really good at it. A way to do that if you don't change it is y is equal to, let's see, you'd have to put in powers of 3. Okay, log base 3 of 3 to whatever power you want. It's kind of weird that way. But I think it's easier for most students to just change it to exponential and plug in a bunch of values for y. So let's do it. 0, 1, 2, -1, okay. What are the values that go with that? Well, x equals 3 to the 0, 1. 3 to the 1, 3. 3 to the 2, 9. 3 to the -1, 1/3. Okay. So, without graph paper, we'll just do our own. And plot the points. Okay, go ahead. 1, 0 is right there. All log functions go through that point unless you shift them. And then you have to go over to 3 to get up to 1. And you have to go way over to 9 to get up to 2. And then if you plug in 1/3, you're at -1. Okay. Remember that graph from last time? We had the exponential doing its thing. Well, the logarithm is the inverse of that guy. And so he is hugging the y-axis downward that way. Notice the domain. This is a college algebra question. The domain of the logarithm function is just positive numbers only. Thank you very much. This is the exponential over here. Ignore him. That's his inverse. This is the curve right there. That's how you do it. That's how I would do the homework, is turn it into, once more, the equivalent exponential form and then plot points. And when you're done, plot your points on the coordinate system. And that's section 3. It's pretty quick homework. Enjoy.